Welcome back, everybody. So our last speaker for this science session S4 is Haifeng Zhang from the Bureau of Meteorology. Floor is yours.
Thanks, Daniel. Hello, everybody. My name is Haifeng from Bureau of Meteorology. Today, I'll be talking about a couple of applications from Southern Ocean Flux Station SOFS mooring. So that will include validation of IMOS L3S SST products, and also I'll show you a case study of a strong SST horizontal gradient event. So before I get started, I would like to acknowledge my co-authors, Helen Beggs, Eric Schulz, and Pallavi Gavkar. So the goal of my talk really is to show you the validation results, very basic, very preliminary results of the L3S product validation against SOFS. And also equally important, I want to demonstrate the good quality of SOFS mooring, and I want to promote this data set. And so in this talk, I'll start with a brief introduction of the SOFS mooring, and I'll move on to show you some results of the validation of the Geo-Polar L3S products. And after that, I'll present a case study on a strong, large SST gradient event. And finally, I'll present some conclusions and a few thoughts on for the future work. So introduction of the SOFS mooring. This is a deep water mood buoy in the Southern Ocean. So the location of the mooring is here. So it's about 400 kilometers to the southwest of Hobart, Tasmania. And this project is funded by Integrated Marine Observing System, IMOS. You should be familiar with that term from Helen over the years. So it's led by Eric Schulz. So the first successful deployment was in March 2010. And this April, we went there to deploy the most recent one, which is SOFS 13. And it's working and it's reporting real-time data to the Bureau. The design lifespan is typically for 12 months, so that will require annual maintenance. It's worth mentioning that it's the only sustained air-sea heat flux in the Southern Ocean. So it provides near-surface mid-ocean measurements to enable us to calculate the air-sea heat flux. In terms of SST, it's at 0.7 meters depth. Given that we know the Southern Ocean is basically an observational desert, it is extremely valuable, this data set, especially in the evaluation of air-sea flux data sets. A couple of photos here. So that is the surface float sitting on the deck, waiting to be deployed into the water. And that's myself actually standing on the surface float, taking photos of the instruments and measuring the heights of the sensors. And also it gives you an idea of the size of the surface float. It's not that big. Okay, let's move on to some preliminary results. So two L3S products actually have been used in this study. For the detail, I'm not going through, there's quite a bit of information on this slide. If you want to know the detail of the data sets, see Pallavi's poster. But I'll briefly mention a couple of key messages. So L3S, the multi-sensor L3S, which is left here, so it ingests polar orbiters only. The geopolar one does not include AVHR from NOAA 15 to 19, but it does include Himari 8. And the SOFS data is the ground truth here. Then, some QC checks on the satellite products and also on SOFS as well. You see the both fonts and you know the key things that I'm doing here. And eventually, during the co-location, I have included all the quality controlled satellite pixels within 5 kilometers to SOFS. So they are included and an average. That means we get one co-location every day if there's available data. And the temporal coverage is from 2015 to 2022. That is totally determined by the lifespan of Himari 8. So yeah, we're going to focus on the geopolar one here. Some fundamental statistics here. Left panel here is the scatter plot for the multi-sensor data, and right panel, geopolar multi-sensor. So a few messages can really stand out. First, we believe that both L3 products are of pretty good quality when validated against the SOFS SST. But compared to the multi-sensor, the Geo-Polar L3S has better temporal coverage. So we have more, like 16% more co-locations. And visually, you can tell that you have fewer outliers in the Geo-Polar one. It has better median bias, and the standard deviation is 0.13K smaller than the multi-sensor product. So yeah, you definitely see some difference. Then we did we look at both products under different environmental conditions, but I'll just show a couple of results here. So this is against wind speed. The left panel here is the bias, the solid lines, and the standard deviation, the dashed lines, as a function of wind speed. The orange is geopolar, and blue is L3S, the multi-sensor. Now, almost under all the wind speed conditions, we think that the bias, the brown line, is actually closer to zero. Especially, I want to draw your attention to this range, like for the wind speed between 10 and 15, there's a quite big difference there. And also, this range is actually, we have quite a lot of co-locations for this wind speed range because, the Southern Ocean, it gets windy there. And another thing is that when the wind speed is really strong, say larger than 18 meters per second, you see this cold bias getting worse. So that's probably something that we need to look further in the future. Similar story here. So this is for the relative humidity, and this is for the down-welling long wave radiation. The bias and the standard deviation for the geopolar one still, I mean, under most of the conditions, it's actually slightly better than the multi-sensor L3S. But if like, for example, when the downwelling long wave radiation is really large, so that means it's likely to be undetected cloud or subpixel cloud. Anyway, so that you have very, very large code bias in both satellite products, and that is also quite interesting. So, and now I want to show you a case study on a large SST horizontal gradient event. A little bit background on how we deploy the SOFS mooring. So every time we go there and we deploy the new mooring first, and we try to make sure the ship circles around mooring for a few hours or even a day or two. Then we go pick up the old mooring, so we pull it out, and so during this overlapping time, we get concurrent measurements from actually 3 platforms. So in this case study, I'm using SOFS 9 and 10. The location of those 2 moorings are here. The average distance between those 2 moorings are 35 kilometers. And here, this is the time series of 21 hours on this April 20th, 2020. This is the SOFS 10 SST time series. This is SOFS 9. and the green is ship SST. So you can see that when the ship is very close to either platform, they match up pretty well. And when the ship transits from one moving to the other, you can see this temperature drop and jumping back again. And in this plot here, the background is the Geo-Polar L3S on this particular date, and it has pretty nicely captured the strong SST horizontal gradient event here. I mean, on average, so we have a 3.5 degree difference across this 35 kilometer distance. It's not that large, but probably the larger gradient can be seen here. So some conclusions here. We have demonstrated that the SOFS time series data set can be, it's of pretty good quality, and it has very high temporal resolution. It's 1 minute. And it's quasi-independent. I think quasi-independent is that we, at the Bureau, we actually assimilated this data set, this SOFS SST into our products. But for any external products, it's independent. So feel free to reach out to me if you want to use this to validate your products. And also we have shown that the Geo-Polar Multi-Sensor L3S has better temporal coverage, and it outperforms the multi-sensor L3S most of the time. We have shown a strong horizontal SST gradient. It can also be captured by the Geo-Polar Multi-Sensor product. And in the future, we might validate the new Geo-Polar product when it incorporates HIMARI-9 SST. And also it is on our to-do list to send the SOFS SST to the GTS in buffer format, because it's already been 13, 14 years, and it's time for the data to be publicly available. And that's it. I'll stop here showing a video taken by Eric on one of the voyages. So yeah, so I mean, that's, we call it a Tuesday in the Southern Ocean. That's it.
Thank you so much, Ivan. Any questions? You don't see questions online. Any questions in the room?
Your comparison between the SOFS 9 and 10 showing a clear difference because of the horizontal gradient. That's very clear, and thank you. And my question is for the match-up distance of 5 kilometers.
Yeah.
So that may partially, I mean, because of a strong gradient, this 5 kilometer gradient distance may partially have kind of result a bias because of a strong gradient, right? So I'm thinking whether you have any test if you make the match-up distance smaller to 1 kilometer or even smaller to see any kind of changes.
Good question. I have actually tried that. I have looked at 1 kilometer, 3 kilometer, 5 and 10. And quite frankly, this strong SST gradient does not, I mean, it's not always there. So 5 kilometers under most conditions, it's okay. And like statistically, if you set to 1 kilometer or 3, over 10 years, it does 5 or 6 years, it doesn't make much difference, because those strong gradient events actually they don't happen that often. And 5 kilometers is a reasonable threshold, I would say. Yeah.
Any more questions? One question from Marwan.
Hi, Haifeng.
Andy has.
I'll take you next.
All right, I'll ask my question first then. Haifeng, thanks for your presentation. Quick question with respect to the generation of the level 3S products. Are you just averaging all the observations within a grid point using all the data from the different instruments?
I'm not sure because I didn't generate the products. My colleague Pallavi
That's
here.
probably me. I produced that data, so I can answer that thing. So we have method developed at the Bureau for the composition of L3S method. So what we do is for every sensor, we use SES bias and standard deviation and reassign the quality levels. And for the composition, we use the highest quality data available for that pixel. So sensors are not fixed. It's the quality that decides which satellite data will go for that pixel. And that quality assignment is totally depend on SES bias and standard deviation.
Okay, thank you. Oh, we'll discuss this later during the discussion part of the session.
Yeah.
Thanks.
Thank you.
Next question.
Okay, Andy Jessup, University of Washington. Very interesting talk. Haifeng, could you go back to the slide where you had the wind speed dependence of the difference between the bias?
This one.
Yeah. So if the satellite measurement is accurate, which it seems to be at across up to 10, 15 meters per second, there's not a lot of data of the bulk skin temperature difference at those higher winds. So could that change in the behavior of the bias actually be a reflection of the physical change in the bulk skin temperature difference as opposed to some instrumentation? Because really, I mean, if the satellite's accurate, what you're showing is the bulk skin temperature difference there, right? Because your SOFS bulk temperature is at 0.7 meters.
Yeah, yeah. But before that, I have converted the satellite SST to depth by adding this constant 0.17 K. And we are also limiting to the wind speed larger than 2 meters per second during nighttime only. So that will give us confidence that it's well mixed in the upper layer. So yeah, so I don't think the cool skin is much of a factor here in this particular result.
But you've done the 0.70 across for all the wind speeds,
Yeah.
the 0.17. So
Yeah.
I'm just wondering if that might be physical as opposed to some other explanation.
Say it again, can you rephrase your question?
I'm wondering if that might be a reflection of the bulk skin temperature difference at high wind speeds where we don't have a lot of data, but there is some indication it may increase, the magnitude may increase at higher wind speeds. It's only one data point, it's just a thought, but
Yeah,
we have some measurements tomorrow that Sandra will show that might be consistent with that.
yeah. Yeah, I mean, yeah, you don't have a lot of observations when the speed is really large, even in the Southern Ocean. That can, I mean, that's definitely a factor to which influences your statistics. But yeah, I'll need to look further into the physics, like when the sea surface is really rough, that could affect the satellite retrievals.
Gary.
Gary Wick, no, PSL. Very interesting. And actually, just building on that, if you go on to the next slide, where you have the dependence, particularly on the downwelling long wave, I think let's have this dialogue after the presentation, because here I think some of that increase as the long wave heat flux is increasing.
Yeah.
You could see stronger cooling, which could be a stronger cool skin present. And so, you could be seeing a signature where your skin is actually cooler, and so your satellite is cool. You subtract off a constant. So I would suggest, potentially that some of that dependence there on the long wave heat flux could be heat flux dependence in the cool skin.
Yeah, good point. I'll look into this further, and we can keep talking.
Any more questions for Haifeng? Thank you, Haifeng. Okay, so this leads us to the final discussion session. We have slightly less than half an hour. We had already lots of discussion during the presentations. I guess this session pointed out very clearly the importance of in situ measurements for lots of ongoing activities within the GRIS community, monitoring the quality and stability of current and potentially future satellite missions, calibration, validation of algorithms, and also all the activities regarding the operational services. I also would like to point out very briefly that recently in some workshops organized by the European Space Agency, it was pointed out mostly by the scientific community, the cruciality of in situ measurements for future space-based, current and future space-based missions, which will potentially also generate some specific fundings for in situ activities. Within GRIS, there are several future missions, especially concerning the very high resolutions that can also certainly benefit from this type of measurements. And I'm sure some discussions on that will arise in the following minutes. I can see Sandra already near the microphone. No, you don't have any specific question?
No, it was a comment.
Please go ahead.
With respect to the GIMP presentation, people ask if the products were put in a common grid, and I checked the original reference from Martin, and at least at the original processing, all the products are put in a quarter-degree grid.
Yeah, sorry. So I think I may have misunderstood some of the questions just now. Yeah, you're right. So I think the process is like this. So we interpret all the analysis into quarter degree and then generate the GIMP median. So the product is quarter degree. Yes.
Before I leave the floor also to Marwan, if you have any additional comments, I can see there is a question on the chat from Paolo Cipollini that we didn't account for previously. Sorry for that, Paolo. I don't know if you're still connected. Anyway, it was a question for Peter Minette. And Paolo was asking about the use of the current orbit drift to get climatological information on the diurnal SST cycle. So I don't know, Peter, if you wish to comment on that.
Yes, that is planned. The diurnal sampling is best at high latitudes where multiple orbits, swaths from multiple orbits overlap. And so we have made an argument to NASA that this data set as the orbits drift can be used to look at diurnal heating at high latitudes in a statistical sense. So that's a good question. And yes, we have thought about it. We haven't done it, but you know.
Thanks, Peter. So Marwan, if you have any additional comments to trigger the discussions, please go ahead.
Yeah, just to extend the topic of the session, which is not only based on the validation of the SST, but also SST gradients, which we just saw in the last presentation. So any comments or any questions about that would be great. If not, I'll have a question for Haifeng, actually.
Haifeng is approaching the microphone.
Yeah,
please.
Standing by.
All right. So with respect, I asked the question with respect to the level 3S products, because when we go for a standard time averaging approach, in the spatial domain, the more instruments we use, the more likely we are to create artifacts in the data. And that's going to impact the accuracy of gradients. So in the example that you showed in a couple of the last slides, have you tried to plot the SST gradients from satellites and compare them to the gradients captured by the ship?
Good point. I haven't, but might be, yes, I might try that, but I haven't, so not yet.
Thanks.
Also have a follow-up comment after Marwan indication on the validation of SST gradients. I was wondering about the use of last generation in situ measurements. I'm thinking about sail drones, for instance, if they can be helpful in validating SST gradients regarding the results of Chongyang. I don't know, Chongyang, if you have any comments on that.
Yeah, so we haven't done anything, but I think that will be a very good data source for some sort of validation. I agree. Yeah. Yeah, basically that. Especially in the coastal areas, I suppose, right? So it's yeah.
Thank you. Do we have any more comments here in the room regarding this topic? Also, potentially the identification of some gaps, necessity regarding in situ measurements to answer some of the topics that have been addressed in our presentations. One point that I was interested in that has not been addressed today, but is also potentially the use of other indirect tools of validation for SST products. This is not strictly a validation as it has been presented here in the presentations in this session, which can be the ingestion of SST for other type of applications. I can just bring a small contribution from my experience, which is based on the monitoring of ocean mesoscale dynamics. So the use of SST to describe dynamical features can also be thought as an indirect tool of validation. And I don't know if anybody has a comment on that. Of course, this restricts the assessment of sea surface temperature data to their consistency in terms of dynamical content. We cannot validate the absolute SST in itself. I don't know if anybody in the audience has any follow-up comments on this.
Well, Daniele, I have a question for you actually. In some of the work that you've done previously, have you started working with SWOT data?
Not yet. Some colleagues of us in CNR have started working on a specific filtering of SWOT data, trying to extract meaningful dynamical information from the current release of the SWOT sea surface site. Hopefully, we will be using some of these SWOT data in future Earth observation initiatives within the European Space Agency. And potentially, I will just present some preliminary ideas in a presentation tomorrow. But it will be a quite natural follow-up of the applications we have been doing until now, certainly, especially for the spatial characterization of the mesoscale features. Thanks for the question, Marwan. Do we have any other comments? I don't see comments online either, so potentially we can move on to the poster session. So thanks very much to all the speakers and to all of you for attending this session. Thank you.
Thank you.
And thanks, Marwan, for co-chairing, of course.
Thank you.